Okay, let's go ahead and get started there, everybody. Welcome back to the next portion of our stream, the Terraria modding portion, where I'm going to continue studying all the guides, all the material that I possibly can to figure out how to go about building the mod that I've been thinking about doing. Um, I was talking to Blackheart one day about like, man, I really wish, they had something like this in the modding so that I can, just kind of look at um, all the equipment that I built and the like. And well, I didn't find anything, and I figured, hey, I need to kind of keep my programming skills somewhat fresh, you know, or at least, try to work on my programming at least a little bit. So um, you know, hopefully I can, um, figure out what, you know, maybe, apply it to, some job that I may get in the future. Um, one would hope. So, okay. I mean, we don't necessarily need the tModLoader screen right at this moment in time. We're not really interested in that too much. Um, I am kind of. There was parts of parts of the code that um, I was questioning. Um, because I wasn't quite sure what they were doing. First was this right here. Why did they include a question mark in this portion of the code? Again, not sure. I mean, it worked perfectly fine, but they included a question mark there, so I don't know why that was included. Okay. Because menu bar was already an established user interface. Normally, when you want to reference a sent function, you use the dot operator um, to pull up, you know, functions that are kind of built into the new interface, for example. Um, but I'm not quite sure what the question mark is, what the question mark does. Um, so that's something that I'm assuming is very C# based. Um, because I've never seen it in C before. At least done in this fashion. At least I have seen the question mark before, but more as a what's it called? It's like a functional equation. I think it's called. It's been a while since I've dealt with, the question mark symbol in C. Um, it was basically meant to, like, if you have like an if-else statement, you can kind of shorten it down into one line with the question mark there. I'm blanking on the name right at this moment in time because it's been a long time since I've had to use it, so I'm not sure. We can look that up. The other part that I want to look up is the delegate. Not quite sure what this is all about. You know, this seemed like it was a keyword in C sharp, so I want to see, um, what this is all about. You know, otherwise, um, I won't have a full understanding of what either of them are doing, and therefore, if I don't understand them, then I might not be able to, um, I might be able to use them later on when I'm writing up the code for like the UI. Like this might be something that is very helpful or useful in what I want to do, in the future when working with C Sharp, building the mod that I'm looking for, right? So let's look up both of these here real quick. So I'm just gonna kind of do a quick search here. C Sharp. Um, hmm. Yeah, conditional operators, but ternary conditional operator. Uh, that's what I'm familiar with, but why did they place it right in front of the dot like that? Hmm. Okay, here it is. Um, okay. Let me show my screen here a little bit. Remove the code. Okay, so before, I'm used to the question mark operator as a ternary conditional operator where um, where you have a certain condition, which will, if true, give you the consequent, or you can go with the alternative kind of thing. Um, so, you know, if you want to, it can be very useful for like, if you want to do something like an if else kind of thing, you can just kind of say, okay, well, if input is greater than or equal to 0, then you can have it be, if that's true, then it's non-negative. Otherwise, you can return negative, and it works just the same, you know for example. So and obviously, as you can see, there's other ways of using the question mark, um, and other coding examples and stuff like that. So it can be a pretty powerful tool if you're if you use it correctly, right? But what I was curious about was this right here. The question mark dot and the question mark, well, I guess array operators. But that brings us to this one here, null conditional operators, question mark dot and question mark brackets or square brackets. So a no conditional operator applies a member access. Okay, I'll have to look that up. Or element access. Let's go and bring those up just, to kind of study those a little bit more. Operation to its operand only if that operand evaluates to non-null. Otherwise, it returns null. In other words, if A evaluates to null, then the result of A question mark dot X or A question mark square bracket of X is null. Or if A evaluates to non-null, the result of that and that is the same as the result of A dot X or X respectively. Okay. Okay, so if A dot X or A, square bracket X throws an exception, these would throw the same exception for non-null A. For example, if A is a non-null array instance and X is outside the bounds of A question mark X would throw an index out of range exception. Okay. The null conditional operators are short-circuiting. That is, if one operation in a chain of conditional member or elemental access operations returns null, the rest of the chain doesn't execute. In the following example, B isn't evaluated if A evaluates the null, and B isn't evaluated if A and B evaluates the null. Okay. If A might be null, but B and C wouldn't be null if A isn't null, you only need to apply the null conditional operator to A. Okay. In the preceding example, B is evaluated and C brackets isn't called if A is null. However, if the chain member access is interrupted, by example by parentheses as in so on and so forth, the short circuiting doesn't happen. The following examples demonstrates the usage. Okay. Whew. So, member access expression, right? Your um, let's see. Oh, okay. So it just led me back up to there. Okay. Yeah. I was thinking that this would kind of lead to something else, or to like, more information, I guess. But nah, it's basically leading me back up to here, which it's just talking about the member access expression. So okay, and then of course the index operator. Right. Okay, not that big of a deal. Okay. So when we look at the code, then it's basically stating that, um, I guess if menu bar is null, then we don't need to worry about the update. You know, so, um, so for example, if menu bar for some reason couldn't be created with a new interface upon load, then we won't need to worry about updating it afterwards, according to that line, because it would be um, the menu bar would be null, and you can pretty much ignore um, the update afterwards. Okay. I mean, um, that seems like it's pretty reasonable overall. Um, it definitely kind of clears up some potential, you wouldn't necessarily need to have it placed within a try catch block to verify whether or not the menu bar is null or not. So that's good. That's useful. Although um, if if you're dealing with this here, stating like, hey, menu bar isn't being created and therefore, or menu bar is null, then shouldn't you have that up there as well? Hmm. I mean, pretty much like anytime you want to update the menu, or if you're so concerned about the menu bar being null on this particular line, wouldn't you also be kind of having that through other calls as well? Because, you know, if you're if you're concerned about this being null up there, then you should also be kind of concerned about other calls for menu bar as well. So, um, so that's why I'm like, it's it's a little weird with our code. Not quite sure. Um, like to be honest, I don't know whether or not they're even aware of what they're kind of doing by the tutorial. You know, when they first created this, because well, I mean, let's go back to the section, right? So if we go back to our, the UI element guide, the basic UI element guide, okay? Um, you know, they were talking about this section right here. I'm unclear on the next part, but assume it's needed, so here it is. So basically they threw this in, but they're not quite sure why, you know. Um, so this is where things are like, you know, uh, that there are times when you look at code and you like go, okay, why did someone build it this way, right? This is one of those times where it's like, okay, well, if once again, if you have this as something that you're checking the menu bar out for whether or not it's null, then again, why don't you have that for the others as well? And I don't even know if they've understood that part. Like, um, like they're kind of going at this haphazardly, and I mean, it works for them, but um, like if ever a time when like the menu bar ever does become null, which I'm not going to say it's always going to happen, okay? Because, um, you know, um, you would figure, you know, when you're creating a new object, such as menu bar, for both of these, you're creating a new menu bar. Um, you're basically creating, a memory space for these two values, right? Menu bar and underscore menu bar. So, um, so the thing is that um, if if you think about it, if they're concerned about this being null here, then they should kind of be concerned about it being null up there and other references of it, like down here, for example, as well. So that's why it's like, okay, well, this could be. I mean, um, this could be quite powerful if you use it properly, but it doesn't feel like they are. Um, so that's why it's like, okay, well, so and again, once again, this is just to check to see, you know, um, whether or not A evaluates the null in like this kind of example of like you know A question mark X. You know, if A evaluates the null, then this also evaluates the null, meaning that it won't really happen. So, um, yeah, see, the null conditional operators are short-circuiting. That is, if one operation in the chain of conditional member or elemental access operators returns null, the rest of the chain doesn't execute. So, um, B isn't evaluating if A evaluates the null. So, so if A is null, then we don't need to do B. We don't need to worry about B. Um, and if B is null, then we don't necessarily need to worry about C. That kind of thing, right? So, um, so that's why, you know, um, this short circuiting can be potentially pretty powerful, but it also could be kind of dangerous too, because if your program really needs it, like if your program, let's go back to our code here. If your program really needs this menu bar, then you might want to have some other check in there to verify whether or not it really needs that menu bar and to activate it afterwards, right? Otherwise, if your menu bar isn't being created, if this menu bar evaluates to null, then you got some other issues going on. Okay, so it can be very rare to have on the menu bar, you know, the it's kind of very rare for like the new menu bar to evaluate to null unless you're dealing with like some form of memory issue, whether it's well, I mean, it's kind of dependent on your CPU, your RAM, and maybe even your hard drive if you have it. Um, if your CPU kind of sends memory usage through your hard drive as well, right? You know, it might try to do that if you kind of have it set up that way, but more often than not, it tries to handle all of its usages through the RAM, right? Um, well, I mean, first it would try to, the CPU would try to go through like the cache that's next to it, L1, L2, and then it would go to the RAM, and then maybe it would try to reference the hard drive, but obviously that's super slow. Or at least that's how it was back in the day. I don't, no, they might have changed things around since then. I don't know. It's been a long time since I've done really any kind of like major hardware programming. So they might have upgraded since then, but I would imagine that it's still pretty much the same. Maybe. um, I mean, we're getting into quantum computing nowadays, so I mean, things are most likely um, changing quite a bit. So, I mean, it can be um, it can be quite a bit to try to stay up to date with all the changes that are going around. So, um, but obviously, that's part of our job as programmers, right? Try to stay up with the times, or at least try to. Um, but still, once again, if we're checking to see whether or not menu bar is null here, then we should be kind of checking to see whether or not menu bar is null in others as well. So, um, like here. Because if menu bar is null, then set state is going to have a problem. So, you're basically trying to set state to the menu bar. You know, if menu bar is null, then you're causing yourself some additional issues along those lines, right? So, um, so technically, you probably don't really need this if you're confident of the menu bar um, not evaluating to null. But that's the thing. When you're creating a new instance, you should probably still kind of check for that anyway. You know, you should probably have those checks in there just to verify, did you actually create said menu bar? Because if you don't and you're, continuously using them over and over and over again, then you're just gonna keep on having crashes and stuff like that. And yeah, it's gonna be a mess. So, um, so yeah. Which, again leads me to believe that, when they were writing this up, they were probably pulling it from either from like an outside source, or maybe they were kind of pulling it um, from the creator of Terraria's webpage. I don't really know. I'm not quite sure, where this particular tutorial got their information from. But, you know, again, if they're unclear, then um, then maybe they should have had some, maybe the original creator said function probably should have had some comments there to state why they're checking for null, on that particular update UI. Why would menu bar suddenly become null? You know, that's what I would be questioning, you know. what's happening, you know. Um, so so that's all. That's what I would, and that's what I would be asking them, you know, for this if I had like, direct communication with the author, you know, of site code. Why did you put that null, um, you know, the null conditional operators? Why are you using the null conditional operators there and not anywhere else? You know, what is it about update UI that, makes you concerned about the menu bar losing its reference? You know, that's what I would be that's what I would be wondering about. So, um, obviously, anything that is like updating, in the game, because most likely like the updates would be kind of being like referenced every tick, right? It's checking like majority of the updates to see, if there's been any kind of change or anything along those lines, right? But typically one would figure. Um, so um, so if it's happening, if these updates are happening every single tick, then um, what could have caused the menu bar to to basically lose its reference and become null. That's what I would kind of wonder about. You know, what would happen? What's happening that you already have a problem, or you have a problem with the updates. So, um, is there some point in the code where they reuse that particular variable elsewhere, that user interface in another part of the code, and therefore basically clobber the reference? And if that's the case, then yikes, that's going to be a bit rough. Um, but don't really know. Okay. The next thing that I want to talk about is the the delegate. So let me look up the information on that now. So okay. Let me go ahead and bring that web page up. There we go. So delegates, C# programming guide. So a delegate is a type that represents references and methods with a particular parameter list and return type. When you initiate a delegate, you can associate its instance with any method with a compatible signature and return type. You can invoke or call the method through the delegate instance. Delegates are used to pass methods as arguments to other methods. Okay. Um, I mean, you were able to kind of do that with function pointers through C and C++. So I guess um, this is their way of like you know making it potentially easier to use function pointers. So you can just kind of call them delegates, and there you go. Um, Delegates are used to pass methods as arguments to other methods. Event handlers are nothing more than methods that are invoked through delegates. You can create a custom method and a class such as a Windows controller and call your method when a certain event occurs. The following example shows a delegate declaration. Okay, any method from any accessible class or struct that matches the delegate type can be assigned to the delegate. The method can be either static or an instance method. This flexibility means you can programmatically change method calls or plug new code into existing classes. Okay. In the context of method overloading, the signature of the method does not include the return value. But in the context of delegates, the signature does include the return value. In other words, a method must have the same return type as the delegate. Interesting. Okay. This ability to refer to a method as a parameter makes delegates ideal for defining callback methods. You can write a method that compares two objects in your application. That method can be used as a delegate for a sort algorithm. Because the comparison code is separate from the library, the sort method can be more general. Okay. Function pointers support similar scenarios where you need more control over the calling convention. The code associated with the delegate is invoked using a virtual method added to the delegate type. Using function pointers, you can specify different conventions. I gotcha. Okay. Okay. Delegates have the following properties. Delegates are similar to C++ function pointers, but delegates are fully object-oriented. Unlike C++ pointers to member functions, delegates encapsulate both an object instance and a method. Gotcha. Okay. Um, so yeah. Okay. Um, so yeah, indeed, pretty powerful. Delegates allow methods to be passed as parameters, right? Delegates can be used to define callback methods. Delegates can be chained together. For example, multiple methods can be called on a single event. Okay, makes sense. Methods don't have to match the delegate type exactly. For more information, see using variants in delegates. Lambda expressions are a more concise way of writing inline code blocks. Lambda expressions in certain contexts are compiled to delegate types. For more information about lambda expressions, see lambda expressions. Okay. So they don't really show an example of it per se, other than this. But I mean that doesn't necessarily give a like a concise um, description of it, or it doesn't necessarily show you know how to go about using it, or what an equivalent would be, kind of thing. Like, here's your delegate, or you'd have to use this, or you'd have to do something like this to do basically the same thing. You know what I'm saying? So, let me see. Um, um, let's see. Delegator's type of safely encapsulates a method similar to a function pointer in C and C++. Unlike function pointers, delegates are object-oriented, type safe and secure. Type of delegate is defined by the name of the delegate. The following example declares a delegate named callback that can encapsulate a method that takes a string as an argument and returns void. Delegate object is normally constructed by providing the name of the method, and delegate will wrap or with a lambda expression. Once a delegate is instantiated in this manner, it can be invoked. Invoking a delegate calls the method attached to the delegate instance. The parameters passed to the delegate by the caller are passed to the method, and the return value, if any, from the method is returned to the caller by the delegate. For example, we create a function that takes in a string and then just writes out that particular message to the console. Pretty simple in this particular context of the function, right? So, and we already have the delegate having the callback with the message in there. So we create the variable of callback as a handler that references the function that it calls, and then it just says, okay, well, handler, you now take in this string that basically gets sent to this, right? But because we've already kind of set like hey, this handler is equal to this one, it then sends that message to this function that it's referencing. Put the message right in there, and then the message will be sent to the console to write out hello world. So, interesting. Okay. Hmm. Okay, here's that callback, and then they're passing in, you know, they're passing in, or they're passing in, a, callback, and then the variable name in there. But you don't have, um, you don't have it like being equal to the, you know, you're not having it reference any other additional method with it. So, oh, okay, okay. So it's still using the delegate method up here. They're just kind of adding on that, hey, you can have another function here, putting in like different parameters, and um, you're basically saying, okay, well, here's a reference to callback, which you then pass in the handler, which we've kind of built in here that's already, equal to delegate method already. So, this gets sent, you know, um, we have the handler coming up here, and here's the string that it's trying to build, and obviously, you have the 1 and 2 and so on and so forth, which gets processed here. 1 plus 2 is, equal to 3. We convert that number into a string right there. And then, you have on the console here, right line, so it basically says the number is 3, so gotcha. Okay. Um, hmm. Okay. Yeah, multiple methods with string messages in there. You're tying them to a specific callback for both of them. And then, of course, you have the D3 is equal to delegate method that we, saw up here, right? And then you're creating a callback that has the D1 and, adding to D2. So, you can have a message here saying hi, and then you can have another message up here saying world, for example, right? So it basically adds those messages together saying hi world or hello world. Although you probably still want to have that space in there to make sure that, you know, um, it still works perfectly fine. um, and then it adds that to the string that is part of the delegate method already. So, although, you know, like delegate method doesn't necessarily have like a string associated with it per se. It's just like, hey, hey, I just want this particular um, you know, it's just taking in that message and putting it on the console. So, but I mean, you basically have it continuously appending to it. So, okay. Um, okay, so interesting. Um, like, I can see how this can be quite powerful. Um, at the same time, um, I might have a little bit of difficulty trying to figure out like, when I would like really need to use it, for example. Um, myself, like I would probably struggle as to like, you know, um, when it would be like a good time to use it and when not to, right? You know, um, so that's one problem that I would probably have to kind of face myself. Um, because it it doesn't necessarily seem like it would be something that would be very common. Um, but at the same time, um, it would kind of eliminate the need to um, like constantly having to like declare objects to reference functions and stuff like that. You could just kind of put it that within the delegate and it can, pretty much be handled. Um, So right here, it's basically saying, okay, well, we're just gonna have this, handling the draw over and over and over again for this particular delegate every time we handle our insert. Um, but at the same time, I'm looking at this and going, okay, well, why? Why do you even need to worry about this per se? Hmm. Let us look at this legacy game interface layer and see what that's all about. So, um, let's see. There it is. Okay. Well, we have the string name of said, you know, of said interface. That's fine. Game interface draw method, draw method. Okay. Um, hmm. Hmm. Okay, so on one hand, it's like, okay, well, I can kind of see why they would want to use the delegate to be able to invoke, a method within a method, right? You know, being object safe and all that. But again, I'm wondering why, you know, um, why is it, why would you need to have um, what this, this right here is, um, acting as though we're gonna need to have like multiple different, um, draw methods, or this game interface draw method is like, okay, well, there's something more than just draw that's part of the game interface draw method that can be kind of referenced here, and that's where it's like, okay. Let's see. Let me look at the game interface draw method here and see if we're um, hmm, I'm not seeing it here at all. Hmm. Okay. Let's look at draw here and see what we can. Maybe it is part of like the game interface draw method, and we can try to find. Oh, I can't even find draw up here either. Okay. Okay, well, this is a bit interesting because menu bars accessing user interface that is calling up draw there, but yet we look at this and we're not seeing, a user interface with draw. So it's like, am I losing my mind here? And we're not finding this one either, and that's a bit. And we're not seeing that at all. Okay, well, I'm, not sure what's going on here. Hmm. So, okay, let me try to put it down into words for this last part before I kind of switch on over to Genshin Impact. But um, so we have the legacy game interface layer, which is what we're seeing here, right? Um, we have the string name and we have the, interface scale type, is equal to, basically this interface scale type dot UI that's down there, right? And then we have this that's basically saying, okay, well, we're referencing a draw method that's under this particular class of game interface draw method to that we can just, where we're placing our delegate within that particular section that we can then just, pull up the draw and, send that into, basically this particular method, right? My problem right now is the fact that um, there's no reference to the game interface draw method anywhere within this API, and like I don't know what other draw methods, you know, might be potentially used, right? Um, like is there some form of like multiple different draw methods? If I do draw and I see all these different draws here, do all these fall in the, game interface draw method portion? I don't know. That's my concern right at this moment in time is that I don't know what all is kind of being um, um contained within the interface draw method, interface class um, part, and there's no reference to it anywhere else within the API, so I'm not quite sure um, you know, what the main, you know, like what other draws can I place within the legacy game interface layer for it to kind of work on, kind of thing, you know. Um, because if it's just draw all the time, then um, I mean, I guess you could still probably potentially still use a delegate there. It's just I don't know. Um, I guess I'm just kind of missing the references here a little bit. What is like the connecting um, material there in that particular case. So, but that's going to be it for this particular session. We're going to go ahead and close on down for this part. I mean, at least we studied up a little bit of that, but I kind of got a little bit more questions than answers concerning the delegate and the legacy game interface layer. Maybe something that I'll have to kind of look up a little bit more at a later time. Um, so, um, try to figure out what they were kind of doing with that. Again, I'm not quite sure why they're not referencing um, um, the null condition operator more. You know, if they're using it once, why are they not using it in other checks as well? Um, you know, I'm not quite sure why, you know, what is it about the update that is different than the load? I know the load is only used once, but still, it's like, um, what is it about the update that requires the null check versus the load? Shouldn't you have both of them there? Shouldn't you be checking null for both in both areas? I don't know. But those are questions for another time. But that's going to be it for today's Terraria mod setting. I'm going to go ahead and close on down, stop the recording right now.